Factoring perfect square trinomials. There are some special situations that have special factoring methods. Perfect square trinomials is one of them. At this point in algebra, you should be familiar with some specific terms. There can be no question of their meaning. Because of this, we need to review some vocabulary. Perfect squares are numbers or expressions that are the product of a number or expression multiplied to itself. 7 times 7 is 49, so 49 is a perfect square. 3y times 3y is 9y squared, so 9y squared is a perfect square. Binomials are algebraic expressions with only two terms. X plus 5 is a binomial. 4y minus x is a binomial. Trinomials are algebraic expressions with only three terms. X squared plus x plus 5 is a trinomial. 5x squared minus 4x plus 1 is a trinomial. Perfect square trinomials are algebraic expressions with three terms, which are the results of squaring binomials. We will work on two examples. This is a binomial squared. It's the same as x plus 3 times x plus 3. Applying the distributive property and collecting like terms, we get a perfect square trinomial. This is a binomial squared. It's the same as x minus 2 times x minus 2. Applying the distributive property and collecting like terms, we get a perfect square trinomial. Pay attention in the following expansions, because we will find patterns for getting perfect square trinomials. Applying the distributive property and collecting like terms, we get a perfect square trinomial. The middle term is twice the multiplication of the terms used to create the binomial expression. You should know this formula by heart. You should be able to take the binomials and find the perfect square trinomial. Let's see how it works. Find the perfect square trinomial for the following binomials squared. Step 1. Square the first term. Step 2. Add twice the product of the first and last terms. Step 3. Add on the square of the last term. Step 1. Square the first term. Step 2. Subtract twice the product of the first and last terms. Step 3. Add on the square of the last term. Step 1. Square the first term. Step 2. Add twice the product of the first and last term. Step 3. Add on the square of the last term. Step 1. Square the first term. Step 2. Subtract twice the product of the first and last terms. Step 3. Add on the square of the last term. With perfect square trinomials, you will need to be able to move forwards and backwards. You should be able to take the binomials and find the perfect square trinomial, as we just did. And you should be able to take the perfect square trinomials and create the binomials from which it came. Pay attention. We know the expansion of this binomial is this trinomial. So the factorization of this trinomial is this binomial. We know the expansion of this binomial is this trinomial. So the factorization of this trinomial is this binomial. So a perfect square trinomial can be factorized into a binomial multiplied to itself. Let's see how it works. Factorize the following trinomials. In a perfect square trinomial, the first and last terms will be perfect squares. Now, we should find the square root of both perfect square terms. To get the middle term, we have to multiply the two square roots together, and then by 2. We should get the positive or negative version of the middle term. Therefore, the trinomial can be factorized into x minus 4 times x minus 4, also written as this binomial squared. In this trinomial, the 26 is not a perfect square, so this trinomial is not a perfect square trinomial. If you do not have two perfect square terms, then the trinomial is not a perfect square trinomial. The first and last terms are perfect squares. Take the square root of both perfect square terms. To get the middle term, we have to multiply the two square roots together and then by 2. We should get the positive or negative version of the middle term. Therefore, the trinomial can be factorized into x plus 5 times x plus 5, also written as this binomial squared. The next example you should try to solve by yourself and then check the full resolution. If you enjoyed the content of this video, don't forget to subscribe. And if you have any questions, feel free to ask or suggest anything. I will be grateful.